Here we're looking at a normal distribution again. Mean, okay, again, means halfway point in between the data. Okay, standard deviation. Now we're going to go randomly pick out an x value. So randomly picking a person, whatever we're looking at, but in this case it's an x value. And we want to find the probability that we find an x that's less than or equal to the mean. Okay, so we want everything that's below the mean. So we want this part, this part, this part, and this part. Well, if we remember about a normal distribution, that half of it's got to fall below, so 50% is below the mean anyway. Okay, now we want probability, so probability we're going to convert that to a decimal, so this is going to be 0.5. The probability of picking a value that's less than the mean. Similar type problem. We're looking at probability. In this case, we're looking at the probability of picking an x that's greater than or equal to x plus 2 standard deviations. Alright, so I'm bringing back the bell curve here just so that we have a visual. Alright, so we want to know we want to pick an x that's greater than or equal to x bar plus 2 standard deviations. So we're wanting this information. Well, not information, but we're wanting to pick an x that's greater than this. So what we'll do is we'll add these together and we end up with 2.5%. Now we're looking at probability, so with probability, if we move it over 2 places, it's going to be 0.025. So the probability of picking a value that's greater than 2 standard deviations is not very likely. If we look at the other way, let's say we were looking for x to be less than or equal to minus 2 standard deviations, okay, then we would be looking at the bottom tail of this, so we'd be looking for this part, and we'd have the same probability here, because again we would add these two together, and we would end up with 2.5% again, which is 0.025 as a probability. So the probability of picking something above, or 2 standard deviations above, or 2 standard deviations below, is not very likely. Alright, let's look at another example here. We're looking now for the probability of x being between the mean and 2 standard deviations above. So let's look. See what that's asking us for. So the mean again is here. That's our mean, and we're wanting it to fall between the mean and plus 2 standard deviations. Okay, and so what we'll end up doing is adding this and this together. So we end up adding 34 and 13.5. So we end up with 47.5%. Okay, but again we're looking at probability. We're not looking for how much of the data falls within there. So it'd be 0.475 as our probability. Alright, let's look at another example with this. Here we want x. We're going to go pick an x value randomly, and we want to know the chances of it being, or the probability of it being greater than the mean. So we want it to be greater than the mean. So it's everything this way. And we know everything above the mean is half the graph, which would be 50%. But again, we're talking about probability, so that's going to be 0.5.